Okay, we similarly said we let us find the concentration of Cr2O7 2 minus. The same way we do take the number of mole that we found up and we divide it by the volume taken, which is 10 milliliter. Okay, 0.013 divided by 0.01 liter, 10 milliliter, we get it's 1.3 mole per liter. But there is another method which is very short. We can follow in calculation. What is this method? K2, Cr2O7, when we ionizes it in water, it gives 2K plus Cr2O7 2 minus. Okay. Shortly, if the concentration taken is if C given of the compound is 1.3 moles per liter, then concentration of K plus would be 2C, which is equal to 2 times 1.3, which is 2.6 mole per liter. And this one concentration, the Cr2O7 2 minus will be also C, which is 1.3 mole per liter. Okay, the same answer that we got above. But in order to perform it, correctly and accept it for official exams, we have to start always with number of moles. Here you can calculate it with shortly and simply. But in order to follow the conditions of the official exam, we have to start with moles. How to start with moles? Like that. Write the relation by mole between N, the formula, on relation. We call it relation till now. Later on, we call it stoichiometric ratios. Today, in this lesson, we use it as a relation. Number of mole K2Cr2O7 divided by its coefficient, the number that is multiplied by here, should equal to what? To number of mole of K plus divided by 2 by the coefficient is equal to the number of moles, let's see, Cr2O7 2 minus divided by 1. In order to change the number of mole into concentration that is required to calculate, just say all of these species, K2 and K plus and Cr2O7, all are existed in same beaker. And same beaker means same solution. Same solution means same volume. Okay? So we write, instead of writing too much, we can say that these are all are okay, all are in same solution, which means that they all are in same volume. Okay? Okay. Are in same volume. So if you divide it all by V, N over V, N over V, N over V, you can transform directly, they can transform these ratios into concentration. Concentration C there for the compound is equal to concentration divided by 1 equal to concentration of K plus divided by 2 equal concentration of Cr2O7 2 minus divided by 1. We transform directly by saying these words. All are in same solution, all are in same volume. We can transform mole into concentration. Instead of these words, we can say divide by V, divide by same V, V on V, we get concentration because N over V is concentration. Then you can write C is given, which is equal to 1.3 equal to K plus over 2 cross multiply بيطلع معنا K plus equal to 2 times 1.3 we get 2.6 mole per liter. Okay, the other one Cr2O7, okay, is equal the same as K2C and C is equal, C here is equal to K2CR27 implies that, okay, implies that, okay, we can say that Cr2O7 concentration, the Cr2O7 equals C equal 1.3 mole per liter. Okay, I advise you to follow this proportion of this ratios because later on we have to find a relation between ions, between cation and anion, not only with the formula unit. Okay, but always write the relation as ratios like this. The third part of the okay, let us solve the last part and then we finish the period, the lesson. Part 3. Part 3 is very important. Let us read what is in part 3. Mixture of ions. Okay. Here we have a mixture of two solutes of common ions. This part, we will solve it and we will solve another kind of such parts later on. First of all, we have a beaker. We have a beaker. Okay. We have a beaker of capacity 250. And the first, we have two beakers. Suppose that we have two beakers. First beaker, it is containing volume 1, volume 1, 20 milli of what? Of this substance, K2CR2O7, of concentration that is taken up here 1.3 mole per liter. Okay, it is to be added or to be mixed with another solution. This is S0, this is S prime. S prime containing a volume V prime is equal to 40 milliliter and of concentration C prime 0.5 mole per liter. Okay. The solution has 0. Okay. Solution as 0, let us label it as 0. Volume 0 and constant. When you mix them together, you get them all in one beaker, okay? You can get them all in one beaker. The volume total will be V0 plus V prime is equal 20 plus 40, okay? Which is equal to 60 milliliters. So we have a new volume, a new total volume. The question is about calculate the concentration of each ion. Let us, okay, see what are the ions that are included. In the first one, K2, Cr2O7 It's in water, can ionize this completely to give 2K plus Cr2O7 2 minus. And the second one, which is, we didn't write it, which is sodium dichromate. Here we have sodium dichromate. In this beaker, we have sodium instead of potassium. Let us also write the ionization equation of this. Na2Cr2O7 in water is to give Na plus dichromate, 2 minus. These two combined, compound 1 and compound 2, they are different ions, different cations. K plus in the first, and A plus in the second. Cr2O7 2 minus in the first and Cr2O7 in the second. These are called common ion. Common ion. Then in the first, what I have, how can I work safely؟ كيف بقدر اشتغل بطريقة ما اغلط كتير. In order to work safely, you have to calculate number of moles. Okay? In the first equation, you can write N of K plus over 2 equal N of K2Cr2O7 over 1. Okay? First of all, you have to calculate the concentration of each. To calculate the concentration of each, you have to calculate the number of mole of each, K plus and Na plus, and Cr2O7 from the first compound and Cr2O7 from the second compound, and you get the number of mole of each, and the number of moles that you get, you have to divide it by the new volume, and you find the result. First of all, N of K plus, خلينا نعمل, let us write the title. First of all, find the title. We have to find the concentration of Na plus, question mark. Okay, concentration of Na, okay, 1. Okay, Na plus, yeah. Let us, Na plus is equal to number of mole of Na plus present divided by what? Divided by the volume of the total mixture. Na plus is existed in S prime. هيدا solution is S0, هيدا solution is S prime. Okay, you know that N of Na plus divided by 2, this is it, okay, it should be equal N to the compound of this compound divided by 1. Implies that N of Na plus equal to 2 times N of Na2Cr2O7 equal N of Na2Cr2O7 يعني equal to C prime times V prime. You can, okay, replace N equals C prime V prime. I know that they are difficult, but if we repeat it many times, they become easy. 2 times C prime is given 0.5 times V prime, which is 40. We'll change it into liter. Okay, we change it into liter. Okay, and we get an answer. We get 0.04 moles. The answer that we get, this answer that we get divided by volume total, you find the result. And A plus is equal in S طبعا in the total mixture, in the mixture طبعا now is equal to the number of mole, which is 0.04 divided by the volume total, which is 0.06, and 4 over 6, we get what? 0.666 mole per liter. Similarly, we do with K plus. Okay, another title, K plus. K plus. How can we calculate K plus? Question mark. K plus is equal N of K plus divided also by the volume total. How to calculate K plus and S prime? K plus, now we can write also N of K plus divided by 2 equal N of K2 CR2O7 or divided by 1. So N of K plus equal 2 times the salt, the way N of K2 CR2O7 is equal to 2 times C0 times V0. Okay, equal 2 times C0 is 1.3, V0 taken is 0.02 liter. The answer is 4 on 0.052 mole. Okay, the question, the answer of K plus equal number of mole, which is 0.052. We divide it by volume total, which is 0.06. Okay. 0.052 by calculator equal to 0.06. Answer is 0.866. 0.866 mole per liter. Finally, let us treat number of mole of N of CR2O7 have then question mark. It is of two sources. And CR2O7 are coming from K2CR2O7 and they are coming from Na2CR2O7. You have to find each and you add. First one. First one is that N of S0 is equal the same as the K2CR2O7 times 1, the same, is equal to C0 times V0 is equal to 1.3 taken, double volume taken, which is 0.02. We get 0.026 mole. Similarly, for the number of mole of CR2O7 and the other one, which is S prime, and S prime is equal to N of Na2CR2O7 times 1, okay, equal to C prime times V prime. C prime was 0.5 and times 0.04, we get 0.02 mole. Just you have to add them. N of CR2O7, 2 minus total, all of them will be N0 in the first solution and S of CR2O7, 2 minus and S0 in the first solution, then N prime in the second one, okay, and S prime. First we have 0.026 and the other 0.02. Finally, we get 0.046 mole. To find the concentration, just divide the number of mole you calculated. Just your concentration of CR2O7, 2 minus, equal N of CR2O7, 2 minus total, okay, over the volume total. What do we get? We get 0.046 over the volume total, which is 0.060 liter. 6, okay? Okay, we can divide 0.046 divided by 0.06. Final answer 0.76766 mole per liter. The question is finished now. I hope that you read it again later on. Next time, we can summarize the lesson. This is the case. This case, we call it in case of mixing two solutions having a common ion. But we still have also like another kind of mixing of two solution of same solute, not of common ion, same solute. Then what we did here اللي عملناه هون هو التالي انه ان here هون بالاخر سؤال اللي هو يمكن اصعب شيء after mixing two solution together. اوكي، هاي الكيس، هاي الحالة اللي عندنا اياها هون، هيدي mixing. The case here we call it mixing of two solution having common ion. Mixing mixing is this case mixing of two solutions having or have a common ion in between. You have to add to find the number of mole of each. Number of mole, you can find it by the relation that we taught you here. N of Na plus over 2, N of Na2 Cr2O7, etc. Only the dichromate, because they are from two sources, you have to find the number of one in each source, and then you can add them, and finally you divide it by the volume total. Okay. We will stop now. Okay. Now, Hassan,
Yes, yes.
Yes,
review this question, review it well. Later on,
Okay.
next time, we make a summary for the lesson to become easy, and then we solve more about it. Okay.
okay.
يلا نشوفكم.
Okay, start. Bye.
Bye.
يلا
Bye.
باي.
Bye.